All right, today we're going to solve two-step word problems using the standard subtraction algorithm, fluently modeled with tape diagrams, and assess the reasonableness of answers using rounding. So a company has 3 locations with 70,010 employees altogether. The first location has 34,857 employees. The second location has 17,595 employees. How many employees work in the third location? We're going to draw a tape diagram and label it to solve this problem. There's a tape diagram right there. What do you understand, or what do we know, and what do we not know about this problem? So we know the total number of employees, which is 70,010. We know the number of employees at the first location, which is 34,857. We know the number of employees at the second location, 17,595. We do not know how many employees are at the third location, and so that's what we have to figure out today. So we're going to use our tape diagram to estimate the number of employees at the third location. I would round to the nearest 10,000. So if you round 34,857 to 30,000, and you round 17,595 to 20,000, that's about 50,000. So the first two locations are about 50,000. If I know the total number of employees is about 70,000, that means there should be around 20,000 employees at the third location, give or take. All right, so we have to find the precise answer. Think about where you're going to start first. And we have to label the unknown part on your diagram and make a statement of the solution. All right, so you have to first thing you got to do is you got to add those two numbers up, 34,857 and 17,595. Once you have that, then you can go from there. All right, so if you subtract 70,010 minus 52,452, you get 17,558. Is that a reasonable answer? Yeah, because 17,558 is really close to 20,000. And that was our estimate, so that does make sense. All right, here's our next problem. Owen's goal is to have 1 million people visit his new website within the first 4 months of it being launched. Below is a chart showing the number of visitors each month. How many more visitors does he need in month 4 to reach his goal? So the best way to do this, we're going to do a tape diagram. What strategy we use to solve this problem? Think about that too. There's our tape diagram. His goal is 1 million. So we can find the sum of the number of visitors during the first 3 months. And then we subtract that from 1 million to find out how many more visitors are needed to reach his goal. We can make an estimate first. And we get to explain our reasoning. So what could you round it to? Well, you can round to the nearest 100,000 and estimate. Owen will need about 200 visitors to reach his goal. I rounded to the nearest 10,000 to get a closer estimate of 170,000. Okay. So you got to find the total for the first 3 months. So you got to add 228,211, 301,856, 299,542. So first add those 3. When you add those 3, you get 829,609. Now we can find the missing amount. think about the actual and estimated solutions. Are they reasonable? Yes, because our estimate of 200,000 is close to 170,000. Yeah, it's off by 30,000, but it's still pretty close. We round it to the nearest 100,000. 170,391 is 200,000. 200,000. I'm sorry. 170,391 rounded to the nearest 10,000 is 170,000, which is also our estimate. So our solution is pretty reasonable. Okay, so our next problem here was there are 12,345 people at a concert on Saturday night. On Sunday night, there were 1,795 fewer people at the concert than on Saturday night. How many people attended the concert on both nights? We're going to draw a tape diagram to solve this problem. And think about, how would you solve this problem? So there's our tape diagram. We have Saturday night right there. We got to find Sunday night. And we have to add that number to the people on Saturday night. I'm sorry, we can't find the number. We don't have Sunday night. We have to add that number to the people that on Saturday night. So we're going to make an estimate of the solution and explain our reasoning. So first we round to the nearest 1,000. The number of people on Saturday night was about 12,000. The number of people fewer on Sunday night can be rounded to 2,000. So the estimate for the number of people on Sunday is 10,000. So it's about 12,000 plus 10,000 is about 22,000. So we think P is going to be around 22,000. So we're going to find the exact number of people who attended the concert on both nights, and we're going to find the exact sum. All right, so when you do that, you get 22,895. So how did you get that? And let's compare that to our actual and estimated solution. Is our answer reasonable? Yes, it is, because 22,895 is near our estimate of 22,000. 22,895 people attended the concert both nights. All right, it's time for a problem set.